So good morning to one and all. Welcome to Raaonline. I am Dr. Jay Kumar, and today I will take you through the autonomic nervous system, the second part, anti-cholinesterases. So earlier in the first part we have seen about the cholinomimetic drugs, and the second part is the anti-cholinesterases. So here we are going to see the competency is the mechanism, describe the mechanism of action, uses, adverse effects of anticholinesterase. The specific learning objectives for today's talk will be, we are going to see the metabolism of the acetylcholine, how it happens by the enzyme cholinesterase, and we are going to see the differences between two types of acetylcholinesterase enzyme, one is true and one is pseudo, and then the classification of the anticholinesterase drugs, and then we are going to see about there are two types like a reversible anticholinesterase and irreversible anticholinesterase. So we are going to see about the pharmacological properties and uses. And finally the few things like management of myasthenia gravis and the compare and contrast physostigmine and neostigmine, what is the difference between those two drugs. Then the irreversible anticholinesterase is nothing but the organophosphorus compound poisoning, and what are the signs and symptoms, the treatment, and finally a word about the aging of an enzyme, which is important in case of OPC poisoning. So moving into the acetylcholine, if you see the metabolism. So in the earlier talk we have seen about the synthesis of acetylcholine, how it happened, and finally when it is released at the synapse it gets metabolized by the enzyme called acetylcholinesterase. Okay, that is why the half-life of acetylcholine is very short. So how this metabolism happens? See, if you take here the acetylcholine, this is the enzyme which has got a two site. One is the esteratic site where the acetylcholine, you have got the ester structure also that will come and bind here. Then the anionic site where the quaternary ammonium compound, that is the N plus, will come and bind here to the anionic site. Okay, so once it binds, what happens? It forms a acetylcholine cholinesterase enzyme complex. Okay, and that complex will undergo rapid hydrolysis, and finally you get the choline and acetylcholine. In case of the other two categories of drugs which you are going to see, one is the organophosphorus poisoning and the other one is the carbamate poisoning. Okay, what is the difference between these two? So if you take the organophosphorus poisoning, it binds only to the esteratic site and it acetylates the enzyme by binding through covalent bonds, and so it is a irreversible nature. So both this enzyme as well as the organophosphorus substance should get destroyed and the new enzyme has to be generated. So the organophosphorus poisoning where it irreversibly acetylates the enzyme, that is the one important thing. What about the carbamate type of poisoning? The carbamate type is almost similar like acetylcholine only, it binds both to the esteratic site as well as the anionic site, right? And then this one easily gets detached, and then because the hydrolysis still can happen, it is not bound to the through the covalent bond. So still the hydrolysis happens at a slow rate and it can get dissociated. So that is why it is important, the difference between these two types of poisoning. So in case of organophosphorus poisoning only, we can give an antidote called oximes, which we will be discussing at the end of this talk. Whereas it is not useful in case of carbamate poisoning, that is the reason. So now if you take this particular picture, the effect of acetylcholine with cholinesterase enzyme, how the metabolism happens. So the first picture, this is the enzyme you consider. You have got the anionic site where the amino acid residue is here. Okay, and here if you take the esteratic site, the serine and glutamate. Okay, this is the amino acid residue present at the esteratic site. And if you see, this is the acetylcholine where the quaternary ammonium nitrogen is there, the esterified form place is there. So what happens when the acetylcholine combines with this enzyme, forms a complex like the ester position combines with the serine and glutamate residue of the esteratic site, whereas the quaternary nitrogen combines with the other amino acid in the anionic site. So both the places gets attached and forms a complex. That is called the acetylation of this enzyme. So once it gets acetylated, there will be immediately a rapid hydrolysis happens, and what happens? The the water molecules added, and then get that, then the acetylcholine gets separated, okay, and then finally the enzyme is left free and the choline also gets separated, okay. So the choline gets separated, that is the acetic acid as well as the choline gets separated. So this choline is going to be used for reuse, again it is going to be used for the synthesis of acetylcholine. So this is what normally happens in case of acetylcholine and its congeners, the other drugs, right. But what happens in case of like for example the carbamylated enzyme, that is the carbamate group of drugs as well as the organophosphorus compound poison, okay. In case of carbamate group of drugs, right, here it is acetylation, here it is a carbamylation, that is the similar process happens, okay. They bind to the esteratic site alone, okay, and then they undergo the hydrolysis process little slower when compared to the acetylcholine, okay, and finally the the compound gets separated, the enzyme is left free. So all the reversible anticholinesterases which we are going to talk now, like neostigmine, pyridostigmine, physostigmine, they all goes through this process, okay, even though they are the carbamates and they follow these these type of metabolism, and except in case of like for example that is the drug called edrophonium, where they bind only to the anionic site alone, and so normally by diffusion it gets separated. So that is why its half-life is short. So there are few organophosphorus compound poisoning. You have got the phosphate site here binding to the the esterate site, okay, and then the anionic site, it doesn't bind to the anionic site. So because of the covalent binding, it irreversibly bonds to this enzyme, and then it is the hydrolysis doesn't happen at all because of that, okay. So what happens when you treat with oximes, which is antidote, which we will be discussing at the end. The oxime, this is the oxime, that is pralidoxime, where it combines with the phosphate and then it forms a complex here and gets removed. So that is why the pralidoxime and obidoxime, they are used in the treatment of as antidote for treatment of organophosphorus poisoning, but it cannot be given in case of carbamate poisoning, carbamic acid poisoning, okay. So this is the main importance of this, how the each and every drug like acetylcholine, the carbamylated compound and the organophosphorus compound, how they interact with the cholinesterase enzyme